So good day, my name is Jay Legini Serio, and today we are going to present the number system 7 and 8, the conversion of octal and hexadecimal to binary. First, the conversion of octal and hexadecimal to binary. The octal numeral system, or oct for short, is the base 8 number system and uses the digits 0 to 7. As you can see, if we have 0, 1, 2, 3, 4, 5, 6, and 7, and it is all equal to 8. That is why it is called the base 8 number system. An example of octal numbers are 25 subscript 8, 452 subscript 8, 102 subscript 8, and 34 subscript 8. The hexadecimal numeral system is a numbering system with base 16. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we're not going to write 10. Instead, we're going to write A, B, C, D, E, F. So the value of A is 10, 11 is B, 12 is C, and so on. The example of hexadecimal numbers are 2B5 subscript 16, 4A1 subscript 16, 37E subscript 16, and 3D4 subscript 16. So to convert octal to binary, first we need to convert each octal number into 3-digit binary number. And the result is the number formed by the combination of all the bits. So for example, we have 75 subscript 8. So first we need to convert the number into 3-bit binary digit. So we have 4, 2, and 1. So the next one is we need to add the number digits to get the 7. So we need to add 4, 2, and 1. So we're going to write 1. And if we didn't use the number, we're going to write it down to 0. So 4 plus 1 is 5. So 4, 1, the 1 is going to 1. And 2, we didn't use the number 2, so it is going to 0. So 4 plus 2 plus 1 is equal to 7. And 4 plus 1 is equal to 5. So the answer here is these numbers. The 1, 1, 1, 1, 0, 1. So 75 subscript 8 is equivalent to 1, 1, 1, 1, 0, 1 in binary. So the next one is 4, 5, 2 subscript 8. So first we need to convert each digit into 3 binary digit number. And in order to get 4, we need 4 here. So here, number 4 will be equivalent to 1. And the number that we didn't use will be 0. So 2 and 1 is equivalent to 0. In order to get 5, we need 4 and 1. So here. And in order to get 2, we have 2 here. So the 4 plus 0 plus 0 is equal to 4. And 4 plus 0 plus 1 is equal to 5. And 0 plus 2 plus 0 is equal to 2. So we have 2. So the equivalent of 452 octal number to binary is 100 101 010. So the next one is hexadecimal to binary. First, we need to convert each hexadecimal number into a 4-digit binary number. And the result is the number formed by the combination of all the bits. So example of hexadecimal numbers. So A is equivalent to 10, B is 11, 12, 13, 14, and 15. So first, let's convert 2B5 subscript 16. First, we need to convert each number into 4-digit binary number. So in order to get 2, we need 2 here. So this will be 1. And in order to get B, the B is equivalent to 11. So 8 plus 2 plus 1 is equivalent to 11. And number 4, we didn't choose. So this will be 0. And in order to get 5, we need 4 and 1. So here 1 and 1. Here is the summation. And the equivalent binary digit of 2B5 subscript 16 is this, which is 101011 and 0101. So the next one is arithmetic binary.
Good day everyone, my name is Lyrin Nabora and I'm going to represent to you my topic, which is binary arithmetic. The arithmetic operations are additions, subtractions, multiplications, and divisions performed on the binary numbers is called binary arithmetic. In the binary addition involves addition of two or more binary numbers. The binary addition rules are used while performing the binary additions. So, following are the rules for the binary addition. So, in the binary, the 0 plus 0 is equal to 0. Similarly, 0 plus 1 is equal to 1, while 1 plus 0 is equal to 1. And likewise, 1 plus 1 is equal to 0, with 1 as a carry to the next column. So in the decimal number system, this 1 plus 1 is equal to 0, right? And the binary equivalent of the two is equal to 1, 0. So in the binary, when we do the column by column addition, then this one will go to the next column as a carry. Therefore, when we are talking about the column by column addition in the binary number system, then 1 plus 1 is equal to 0 with 1 as a carry to the next column. Similarly, while adding the 1 plus 1, suppose we have carried from the previous column, then the addition is equal to 1 with the 1 as a carry to the next column. So in the decimal, this 1 plus 1 is equal to 3, and the binary equivalent of the 3 is equal to 1. Is equal to 1, 1. Therefore, when we are doing the column by column addition, then in the particular column, there will be a 1, while this 1 will go as a carry to the next column. So these are the few rules for the binary addition. So now let us take few examples. So let's say we want to add these two binary numbers. So as I said, we will do column by column addition. And similar to the decimal number system, we will start from the rightmost column. So in the rightmost column, we have a 0 plus 0. So as we have seen, this 0 plus 0 is equal to 0. Similarly, if we move to the next column, then we have two ones. So as we have seen, this 1 plus 1 is equal to 0 with 1 as a carry to the next column. So now if we move to the next column, then we have 0 and 1 as a carry from the previous column. So effectively, we have 1 plus 1. So once again, this 1 plus 1 is equal to 0, with the 1 as a carry to the next column. So now, in the last column, we have a 2 ones with 1 as a carry from the previous column. So as we have seen, this 1 plus 1 is equal to 1, with the carry as a carry to the next column, since there is no more column, so we can directly write it as a 1, 1. So this is the binary number which we will get after addition and check whether our addition is correct or not. What we can do will convert this number into the decimal equivalent. Okay, next. Next is binary subtractions. Involves subtracting of two binary numbers. The binary subtraction rules are used while performing the binary subtraction. So, following are rules by binary subtractions. So, in the binary, 0 minus 0 is equal to 0, while 1 minus 0 is equal to 1. Similarly, this 1 minus 1 is equal to 0, and 0 minus 1 is equal to 1. When 1 is borrowed from the next column, so in case, since 0 is less than 1, so we cannot subtract 1 from the 0. And therefore, we need to take the borrow, so these are binary rules. We will go through the examples. Subtract the number column by column, the first column. Oh, 0 minus 0 is 0. Second column is 0 minus 1 is cannot be. So borrow in the left side, as we can see, this is also 0. And of course, we can borrow anything from 0. Then finally, there is 1. So now we can borrow. Now let's take a 1, make us a 0. 0 becomes 2. Next, let's borrow from 2. This becomes 1. Sorry. Becomes 2. Next, borrow from 2. Becomes 1. Then 0 becomes 2. Now we can continue to solve. 2 is minus 1 is equal to 1. 1 minus 1 is equal to 0. 1 minus 1 is equal to 0. 0 minus 0 is 0. 1 minus 1 is 0. 1 bring down, which convert the answer. 1, 0, 0, 0 into a decimal, then convert to each binary number into decimal. Let's add all the 1, then ignore the 0. 2 plus 64 is equal to 66. 16 plus 32 is 112. Second row, 2 plus 4 plus 8 plus 32 is equal to 46. 112 minus 46 equals 66. We can see we have the right answer, the 2 in top in decimal form. Next. Next na. The next is the binary multiplication is very much similar to the usual multiplication method of integers. First, we need to multiply each digit of one binary number to each digit of another binary number, and then add them all together to get the final result. So the four major steps in binary digit multiplication are 0 times 0 equals 0, 0 times 1 equals 0, 1 times 0 equals 0, and 1 times 1 equals 1. Next. Now let's try to solve this problem. So we multiply 0 times 1 is 0. Any number multiplied by 0. Next is also 0, so let's put another 0. 2 times 1. 1 times 1 is 1. 1 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. The last number multiplied and times again. If we are done multiplying, now let's add all the numbers. bring down 0, 0 plus 0 is 0. So let's convert each binary numbers into decimal. Let's add all the 1, 2, and 4, and 8, 16, 32, 64, 128, 256, 512 equals 684. Now let's add the top row. 1 plus 8 plus 16 plus 32 equals 57. Second row, 4 plus 8 equals 12. Now let's multiply by 57 times 12, and the answer is 684. Now we can see that we have the right answer. Okay. The last is the binary division operation is similar to the base 10 decimal system, except the base 2. The division is probably one of the most challenging operations of the basic arithmetic operations. The process of binary decimal system. Now let's try to solve the problem. As you can see, the device has 3 digits. So the next step is to look for 3 digits are dividend now. As yourself. As yourself, 1 is 0, 1 greater than or equal to 1, 1. Obviously, no. So let's another digit. Then again, as yourself is 1, 0, 1, 1 greater than equal to 1, 1. The answer is yes. So let's put 1. So let's multiply. Multiply lang yung 1 times 1 is 1. 1 times 1 is 1. Okay. And 1 times 1 is 1. So the next step is to subtract the number. 1 minus 1 is 0. 1 minus 1 is 0. 1 minus 1 is cannot be, so borrow 1. And 0 becomes 2, then 0 minus 1. After subtracting, bring down the number. So again, ask yourself, 1001 greater than or equal to 1, 1. Yes, so let's put 1 on top. So let's multiply. 1 times 1, 1 times 1. Then subtract the number. The next column is 1 minus 1 is 0. 0 minus 1 is cannot be, so borrow the larger number. So let's subtract. 2 minus 1 is 0. 1 minus 1 is 0. 0 minus 1 is 0. 0 is nothing, so 0. After subtracting, bring down the number inside, so we have 1, 0, 0. It is a greater than or equal to 1, 1. The answer is no. So let's put 0 in top, then multiply. 0 times 1 is 0. 0 times 1 is 0. 0 times 1 is 0. Now let's subtract the next. 0 minus 0 is 0. 0 minus 0 is 0. 1 minus 0 is 1. This is called a remainder. Now if you can check your answer, let's multiply our divisor to our quotient. 0 times 1 is 0. Then 0 times 1 is 0 again. Tapos 0 times 1 is 0. 1 times 1 is 1. 1 times 1 is 1. So, again, ulitin lang ulit yun. Then add all numbers. Let's bring down 0. Second column, 0 plus 1 is 1. Then third column, 0 plus 1 plus 1 is 0. Carry 1 next, 1 plus 1 is 0. 0 carry 1 and 0 plus 1 is 1. Last column, 1 plus 1 is 0. Carry 1, so add the remainder, then the answer is similar in dividend. So that's all. Thank you for listening. I hope you learned something.